Hello and welcome. Our topic for the day is factoring difference of squares. To understand the concept, let's do some questions. The first one says factor 25r squared minus 16c squared. Before we go on to proceed with the steps in this, let's see how to do these questions. Always remember that whenever we have difference of squares, the two numbers or the two coefficients should be perfect squares, and the variables attached with it should have even powers. So let's write down the numeric part should be perfect squares, and whatever variables are should have a even power. Then only we can apply this rule over here. Should have even powers or even exponents. So we've learned the formula a squared minus b squared is given by a minus b times a plus b. So using this formula we'll be solving our questions. So let's write down the first one. This is 25r squared minus 16c squared. Now 25 is the square of the number 5 and r squared is r only, like this we can write down. 16 is 4, c squared is c, and all to the power of 2. Now we'll apply this formula, that is a squared minus b squared is a minus b and a plus b. Here a is 5r and b is 4c. So 5r minus 4c times 5r plus 4c. This is the final answer and can be seen in option A. We can even write down in the way the answer is 5r plus 4c times 5r minus 4c. In multiplication, it doesn't matter whether we write a times b or b times a. They both are the same. Therefore, answer is option A. Let's look at the next question. Factor and again 625 k to the power of 4 minus 1. So 625 is the square of number 25. K4 is k squared all to the power of 2 minus 1 squared. So now we can write down the formula. Here we have a is 25k squared. This is a standard identity which we can remember. That is a squared minus b squared equals to a minus b times a plus b. So now we can write down 25k squared minus 1 times 25k squared plus 1. Now we see in the first parenthesis this can still be further factored because 25 is a perfect square. So we write 5k squared minus 1 squared times 25k squared plus 1. Also, this identity is only applicable when there is a negative sign, not a positive sign. So the first two can be factored further as 5k minus 1, 5k plus 1 times 25k squared plus 1. Again rearranging, we can write down 5k plus 1 times 5k minus 1 times 25k squared plus 1. This is the final answer and can be seen in option B. Let's try out the next question. We have factor 81p4 minus w to the power of 4. 81 is a perfect square of 9. p4 can be written as p squared all to the power of 2 minus w squared to the power of 2. So we'll apply the formula now, a squared minus b squared. So we have a as 9p squared and b as w squared. So we write down this as 9p squared minus w squared times 9p squared plus w squared. Now we see the first parentheses can still be further factored because 9 is a perfect square and the powers are also even. So we write down 3p to the power of 2 minus w to the power of 2 times the second parentheses as it is. Now we'll apply the formula here again. I have a as 3p and b as w. So we write down this as 3p plus w times 3p minus w times 9p squared plus w squared. This is the final answer and can be seen in option B. I hope factoring by difference of squares is easy now. Thank you for watching and have a nice day.